Hi and welcome back to the channel. Toby's Video Skills is Toby, that's me. In today's video we want to talk about the AMPINVT. It's hard to say this name. We talk about this inverter. It's a 12 volt up to 2000 watt pure sine wave low frequency inverter. And this little unit seems to be an inverter and charger in one plus the UPS functionality. What does the UPS stand for? The UPS is an uninterrupted AC power. So that means if you have your device, in this case this inverter charger, hooked up to an outlet at your home, 120 volts, and you connect something on the other side, on the inverter side or on the side where you can pull out the power, then it's just leading the energy through. And additionally you can connect a battery to this inverter. So in case, like in America, it's pretty frequent, it looks like, some areas more than others, so that the power goes out. And if that happens, it just automatically switches to the battery without any interruption. It means, for example, I have my computer, it's running, I'm working on something, editing, whatever, and power goes out, and it immediately switches on to the battery, and I won't even reboot, I won't really know it because it's in such a split second, I don't even realize that, but I'm still able to edit. Of course, everything else around me might have no power, so where's the point? But there's a point for all those things. You can connect your fridge to it because power outages, you never know how long they are. Maybe your freezer fridge, you know, when it's connected, hey, who knows? It's great to have that. So, and this video is purely focusing on this one, and I want to compare it a little bit as well with the Victron Multiplus 2000. Why that? Because it's a really fairly similar product, I would say. It is maybe different. I don't know if it's aiming to be the competition. I don't know if they developed it themselves. No idea. But I want to just, keep in mind, it looks like there is a competitor out there which might be sufficient for you. Maybe not. We'll take a look today into the wiring, how to set it up, and we'll test also the functionality, what it comes with. And I start this video in here because I want to show you those pictures and those information first. First of all, let me show you the dimensions, which are here, as well as the weight. And this inverter is a pure sine wave inverter up to 2000 watt, and it has continuously. And it has a peak of 6000 watt. I have to see if I can test that. At least the 2000 watt continuously is something I want to test, and that might be already sufficient for a lot of fridges. No, not a lot, that's wrong, but fridges, AC, depending on really what you want to have running, a small AC, not big AC, especially when it has a peak up to 6000, depending on how long it can hold it. So that might help with turning on the AC and having it powered. We can see the unit I have. I'll show you later when we go to the wiring. It's this unit as well, plus also this remote screen. The remote screen in this case. I saw a couple typos already here. Well, now it's reported. The remote screen is not included. And I also get this remote screen because, when you have it installed, let me say you install it in a van or you've installed it at home. It's nice to have some kind of remote so you don't have to have the unit right in front of you. You have a remote and you can check it if you want to. Because also this unit does not come with any other remote functionality as much as I'm aware. No Bluetooth, no other connectivity to the internet. That is already a difference to the Victron Multiplus 2000. You might think it's a small unit. I was surprised how big it is. I guess that's what it comes with when it's a UPS as well, but also 2000 watt, and it can just lead through the AC power if needed. All right, we'll take a closer look onto the unit in a second, but I want to show you also here that this is the Multiplus. What I like about the description, the Multiplus is a combined inverter and charger in one elegant package. Well, they don't say it's an elegant package, but never mind. Regarding a few more facts or details here, UPS pure sine wave power inverter, 12 volts, it's a pure 12 volt system in terms of your battery. Whatever battery you do connect, it needs to be 12 volt, it cannot be more. It does come with 5 different modes. And those modes, I still try to understand them 100%. I feel like they're a little overlapping. Correct me if I'm wrong, but the first one, AC line priority mode. So it means, I'll show you in the display how that looks like later. So it has, So it has the AC line priority mode. We'll talk about it later on how to adjust it. You have the battery priority mode. So what's the difference between those two? I think that's something I figured out in the meantime. AC mode means when there's AC and battery connected to the inverter, it's always try to use the power from the wall, from the power, AC power. And at the same time, it charges the battery. When there's battery priority, regardless of you have connected AC power, it's using the power first from the battery until it reaches a threshold, so a certain voltage which you can adjust, what's the bottom kind of, and then it stops using that, and then you have to have a different source to charge the battery, so like solar, or maybe a generator. And then there's eco mode. I haven't figured it out yet. When the load is less than 10%, it automatically sleeps and stops. I've not seen that it was coming back up. I have to double check with that. Maybe I was not testing it correct. And then we have a generator mode. I have not used because I don't have a generator, but use unstable generator 120 volts to generate power. It's matching automatically the 50 and 60 low frequencies. And then we have the unattended mode. When the battery is low voltage, the inverter goes into standby state, power saving state. When the battery restores the voltage, value is set by yourself, so that's the voltage you set, the threshold, lower limit, and then a restore limit. So that's unattended mode. So I got confused with 1, 2, and 5. So we'll see. Maybe you can see a better use. Maybe you see the use cases better than I do, but you have different modes which you can use. And so far, when you have a setup with solar charging a battery, I would totally go with the number 2. I think that's an amazing setting, and that works the best. But I think what we do next, we'll look at the unit and wiring everything up to do it properly. And disclosure, I'm not an electrician, so please be careful whatever you do, and ideally don't copy me, but I try to explain what I do, so maybe it helps you to do your research. Alrighty, so here we have it. Sorry, my fan is running in the background. I hope it's not too noisy. I'll give it a try that I can maybe cut it out as much as possible. But what you're looking at here, it's my hand and this massive inverter, charger inverter. So it does come, let me talk about it most obvious first, it does come with those wires. I do not know what gauge it is. I would assume maybe it goes in a direction between 6 and 4. I would assume. It doesn't say anything, it's labeled, but it doesn't say any gauge size, so that's a bummer. It's hard to say. Regarding those crimps, really quick, you can see they have different lugs here on top. One goes to the battery, one goes to the inverter, and they are crimped like this, with this pretty basic crimper, I guess, like a plier or something. So far it was okay. They are heat shrinked, not all the way to cover it, which is interesting. I like to protect a little bit more and just have the surface here being, but I think it will do the job pretty good. So it's solid connection, that's the most important. And we'll connect it in a second. Additionally, of course, the device itself, it was covered here with a screen protect. I used it already a little bit, as you can see, so my fingerprints are all over the place. This is a display area. Then we have some vents, or at least air inlets if needed. Then we have a label here, which feels like it's pretty professional. It even states it is ISO 9001 certified. Then we can see here the model. This model is a FT20212, which I'm surprised is a different model than I clicked on in Amazon. It's rated, it's 2 kilowatt, 2000 watt, AC power is between 93 and 147 at 60 hertz, plus minus 5 hertz. And the AC charger is at 13.8 volt, 35 amps and adjustable. So that's something we need to talk about when we get there regarding the battery. Maybe we can talk about it already, but you will see later when we go and click through the menu. We do not have anything predefined for lithium iron phosphate, which is a huge bummer. And this is something which I would love to see here. If there would be some kind of online connectivity, this could be updated most likely over or via remote, but it's not the case sadly. So we'll continue. Yes, you see right, there's a battery which I will connect, and I'm using the Neomark, which has a 200 watt, 12 volt is a review up there. And I think 200 watts are good for this unit. You have to make sure whatever you want to connect, when you want to connect more than 2000 watt or 2000 watt, you should have a battery which can handle that. Otherwise, it will just fail. So you need definitely a battery which works with that. Additionally, we do have a cover, which I'll show you in a bit where to put this. We do have a manual, a very basic manual. I looked through that. It has in total 13 pages. I think the most important is actually the last one, the technical data sheet. It is very basic information here. Honestly, it was not helpful. I was trying to figure out the 5 modes it was describing. The only thing I found was online. So that's something which would be great if this could be improved. Same with having remote access and the lithium iron phosphate profile. And also it has a product warranty card. All right, those are the things. I'll give you a little tour. So that's the side of the house thing. We have some labeling up here, and this one is basically indicator description. So what we can see is we do have indicator description, basically to flash the lights which are up here on the side up there over the display. It's described what it means. We can see here also how to connect it and how it works. So that's pretty neat, and it's also very simplified. And then we have the working modes, which we can adjust. And then, Pure Sine Wave Inverter low frequency. For me, this is still a UPS. This is a inverter charger. So this is this side. Let's go to the battery side. When I speak about battery side means this is where we can connect our battery negative and battery positive. And it's covered with this plastic, and it requires a 14 millimeter here. I loosened this already to get those plastic covers off. And then it does expose those studs, which also come with a nut, split washer and washer. And I'm just connecting one of the sides, and I will connect one of the sides depending on your battery terminals. There are 2 different lugs on, or you have your own wire, which you can just use and connect here. So anyways, we need to route it this way. And then we can throw on this plastic cover, do the same. Since it's plastic, be careful with tightening it. Don't over tighten it. It's also, there we go. It's also 14 millimeter. We'll do the same here with the positive. When you connect it, you want to have the wire touching the metal here. Then we want to have the washer, and then the split washer, and then the nut. Very important. Make sure the orientation is going down with the wire. Hand tighten it. Put on the protective cover, and there we are. That is all for the battery. And before you connect any AC on the other side, which we'll get there, you have to connect the battery first. Very important. That's what it was calling out. That was one of the things which I actually found helpful in the manual. I want to introduce you one more thing, and that's this remote. And this remote is separately sold. It has basically the same display like it has on this unit. It does come with this display. It has a nice aluminum frame, I feel like. It's aluminum back here, so this is really solid. That's nice. That's actually nice. And it comes also with nice and stainless steel bolts, which look pretty nice when you install this one in the wall. It does also come with the wire, which seems to be a network size wire, so it has like 8 little wires in here. So you connect it in here in the RS485. That is where your remote would be connected, and then they have a pretty lengthy wire, which you might be able to extend if you need to, I guess. Now we'll switch on the other side and connect the AC power. Actually, before we do that, please connect negative and positive to your battery. Do connect one of the wires first to your battery, and what you should do, in my opinion, because you don't want to avoid any inrush of current going through, use one of those little resistors. I have a 50 watt equal resistor, would I just use, hold it, when one side is connected, hold it to the other side and connect it to the other terminal. So in that case, it just makes sure that you do not damage your inverter. So let me connect it to the battery. So let me connect the negative first in this case. In my case, I have 13 millimeter bolts here. The first one connecting, not a problem. Tighten it down. There we go. Before I connect this one, I'm using my resistor, connecting it here. There you can see it. Now I'm safe to connect it here, so that's very important. And I should have loosened this already. And done. Here we have on this side our fuse, AC fuse. We have those three, our AC input. We have an AC output, which could be just, for example, an outlet. And then we have two extra outlets here, and it says output. AC output is maximum 10 amps per. So in my case, I like to make things easy, so I bought off Amazon this one, which comes already stripped, almost stripped. I had to re-strip it a little bit and make it longer, but that's how it comes already. So this one will be my AC input. It means you're not connecting this to a wall, nothing. You just have to make sure you have it stripped far enough back. Our AC input, here we have the neutral line and our ground. So in America, we are in California, America here. Of those three, we need to use the white one for neutral, black for line, and we do have green for ground. So that's how it goes in. As mentioned, you need to make sure it's not connected, and you need a Phillips screwdriver. So undo all of those ideally as far as you can, and then connect them each individually. Put them in as far as you can so they're not sticking out. I'll continue with the other two. And then afterwards, you just check that they're all tight in there. Very important. So then I do provide you with this little cover, which we'll put on just there to make it safe. And we're not accidentally touching it, so they also provide you with those Phillips screws. One is not usable because it's just metal in there, so I'll have to find another one. But you get the idea. It's, you know, protecting you and whoever is there. All right, that's it. What you can connect is over here, maybe an outlet, maybe a hair dryer or charger, whatever you need. And we will now move it over here. All right, let me fire it up and plug in the AC. Here we are. You can see there's some movement, some beeping. Because the display is illuminated, it tries to adjust the camera, sorry about that. So here we are, nice. So we can see it is in, we turn on, no actually, probably not. When I hit this button, enter menu, then I can just light up the display, but let's give it a second. There we are. Now there's no background light on, so this is the display area. We have 5 buttons. We have 4 lights, LED lights up here. So we have the AC, battery, inverter, fault lights. We have an escape, an up, down, and enter menu button, and an on-off button, which acts as turning on off this unit entirely, and also just the inverter, depending on how long you press it. So now you can see in the display itself, we have here the input. That's the input of the AC, so the grid. Then we have battery, voltage, and this is the voltage I'll show you later, which I did say it's the charging voltage. There's not a lot to adjust. I'll show you. Then you have the output of the inverter, 122 volts, and then there's the load. Picture up here is the grid, battery, and the load, and it says it's in AC priority mode right now. So let's click here to illuminate the display, adjust the camera. When you hit longer, enter a menu for 3 seconds or so at least, or maybe 5, it does change into the settings, and then we can use up and down. When I use the down, I can switch to system mode setting, battery type setting, charging current setting, and then also I turned off the alarm setting because I don't like this beeping all the time. The clock you have to set the first time using record, query, and record lead, and then also factory set. So I want to go into, no, not language settings. I want to go into system mode setting first, and you can see we are in the first line priority mode. We can switch between those 5 modes I told you earlier about. I'll stay in the line for now. Go back, don't save it. Switch into system mode, switch into battery type setting, because that's what we should set up first. And then you can see we have those SLA battery, which has already a charging voltage attached to it. We cannot change. AGM battery, and then we have a gel battery, and then we have a lithium and a custom. And I'm hitting yes, I want to do that. and then you can only set up the charging volt. So, and the thing is, it's only stays in charging. It's never going into a float mode at all. There's no profile for that, so that's what I meant. So I can set it to 13.8, which is for this battery probably better, instead of staying all time long on the high 14.2, which is the charging volt, right? So when I hit enter, set successfully, that's all. There's nothing else I can adjust. Versus system mode setting again, and I go to unattended, the last one here, enter, then I can say, okay, the low volt protect of the battery should be, for example, 10.8 for my case. And then we have the low volt restore settings, which is at 12.5, whatever you want to have it, and set successfully. So those are the things you can do. Now we're on an unattended mode. So those are the settings, and now you can see the battery charging when we go up with the arrow. We can see the information, system information, time. We can see output parameters for the AC input supply. And then we can also see the battery parameters, which is battery voltage at 14.2. And battery capacity and charging voltage, we can see it's 13.8. I can see that it's 14.2 because that was a prior setting. It usually takes a little time before it changes that. So that's one downside. If you use an HEM battery, SLA battery, perfectly fine. Lithium iron phosphate, that's the only downside, what I was able to find so far. Escape shows you just the website. And when we want to turn off just the inverter, just the one longer press of here, and then it turns off the inverter, which we'll see is lit up here with this one, but one longer second, and then it turns back up on. Press escape so we can see what's happening here, and here the output is coming back on, and then you see the load could be attached again. Well, that's it about how to wire it up and set it up. I think we'll go ahead and test the unit with the 2000 watt, I would say, and we measure how much this unit in standby pulls. Alrighty, so here we have still, you can see, AC input priority, but we also have the battery connected, so right now it looks like it's charging a little bit. What we're doing next is check if it's a pure sine wave. That means I'll plug in those two. We will go in here, there we go. Right now, AC input priority means it's pulling from the wall outlet, right? So here you can see everything's good. It looks like a pretty solid. Few little interferences here, if at all. You can see it holds the 60 Hertz almost. Pretty solid here as well. Hope that makes sense. You can see that. Let me start a heat gun, which is plugged into the inverter, and for power, which should be around 60 to 70% of load. So now you can hear it in the background, and we can see it's running. The inverter, the fan is kicking in. It is at 66%. I'll show you later when we do the load test a little bit more. I want to now switch over to the battery, which means I will unplug right now when the test is going on the power cord from the AC. Noise, there was a little change, but immediately, you see it here in the background maybe, the orange light went on, so it means now just the pure inverter from battery is pulling the power. And it's still a pure sine wave, pretty nice, pretty good to see. This one should be around 1200 watt, I believe. It's pulling. Let me put in the AC again, so the wall outlet. Here we go. And I heard it clicking, so now it's switched back to the AC power. Now it's charging the battery again. So pure sine wave, pretty good. When we look here at the display, sorry, the sun is coming in more and more, but you can see the input is at 117 volts from the wall. Battery is at 13.3 volts. The output of the inverter is at 118 volts. Load is at 66%. And it's still a pure sine wave. It's nice to see. Let me turn it off. And the fans are slowing down and turning off of the inverter. Or, yeah, no, not completely. There's a standby-ish fan running. But that's good. Pure sine wave. You can check that one off. That's nice to see. So I told you there is some kind of, additionally, this little remote, which is an aluminum frame, and I think this is just a sticker, kind of. And here it's also aluminum, nice solid. It comes with 4 bolts for all corners, stainless steel I would say, and you can read it pretty well. It has the same display, so when you click in here, or at least what it displays here, you can see it's turning on the LED light. It's not happening on this unit, so they're kind of independent, but also depending on what's in the background happening, which is cool. So right now you can see the flashlight, for example, they are not in sync, which I don't think is a big problem, as long as everything is the same what it displays. And so far, all the information were in sync, so that's good. Sometimes I felt like there was a little delay, but not that it's worth really, worth mentioning. I'm mentioning it here right now, but not that it's a problem at all. So pressing OK, you can see it's switching. I can do the same settings what I do also on the main unit. So I can now switch between system modes, etc. So what I want to do next, I'll put this to the side again. What I want to do next is testing how much this unit in standby pulls. And I'll do that mainly from battery, because that's where I can measure it. At the moment I don't have. That's where I can measure it, how much in standby it pulls from a battery. So we'll change. Actually, we don't have to change, we just unplug it, but we can also change. I think it's probably a better test if we change this one. Oops, sorry, let me get this on focus. We want to go. I hope you can still see it. It takes a little second. There we go. I would change to battery priority mode. Hit enter. Low volt disconnect. I want to go to 11 and restore it to all 5. It should be not a problem at all because the battery should be pretty full still. How do you figure that out? You go up or down one of those. Then you have the AC first, and then you have the battery parameters. And that really depends on your charging voltage. However you set that, that's kind of calculating the battery. So it's, for lithium iron phosphate, as I mentioned, a little off, I would say. So it needs some readjustment here, or you keep thinking about it that this is a different calculation here. So now we see in this little picture, let me see, I hope you see that. On the display, backlight turns off. It's easier for the camera, sorry about that. There it is. You can now see there's nothing coming from the grid. The load is getting the power from the battery. Let's see. We are at 2 amps. Let me see that it's not touching. It might be a little, yeah, up to 2 amps. That's what it's pulling. Let me unplug the AC just to be super safe and sure. Now AC is unplugged, and you can test that with up or down, and then you see output parameters, and here status inverter output. And for the battery, it's battery information, but it means that AC is not connected here. And we can also see it with the light. And not only the light, also the display. There's nothing coming in from the grid. So let's see how much are we having here. We still have 2 amps. So stand by. You can calculate 2 amps. That's what it's pulling. Sorry, there we go. Yep, 2 amps. All right. I think it's easier to read with this display actually, which is great. So we are in battery priority mode. Everything we connect to the inverter is pulled out of the battery. There we go. So let's see how much we can actually pull and what happens. So I'll turn on the heat gun, and then we can see here in the corner the load. Less than 70%. I think what I always like to do is going overboard, so I'll connect heater source here because I just need to pull a lot of power. And fan did kick in. What 70% means, by the way, let me show you. We are at 150 amps. Nice. Let's turn on another source. All right. Over 100%, 107, still running. But you were able to hear 126. You were able to hear that everything kind of got slower, but that's also possible due to my battery, because that one is, when you go over 200 amps, that's probably too much for this little battery as well. So you need a really, really strong battery. But let me get back to this one. There we go, to 40, we are 103. still 160 amps. Going strong. There we go. Heater kicks in, gets hot. 30. The heat gun is getting lower. Wow. We're running good. Wow. I'll turn it on because the fault light is blinking and it's telling us, okay, it's over the 2000 watts already. Nice. All right, I'll stop it. All right, that was just purely the battery, and I'm pretty sure the battery is the weak spot here. Not a weak spot, but it's not sized and meant to be pulling so much amperage for a very long time. All right, I had to do some readjustment testing. Unpower the unit completely because it was not charging the battery. I don't know why. Right now I'm in AC mode. Oh, you don't see that. Here we go. Battery is charging with around 20 amps. This device, this inverter charger, is rated up to 35 amps at 13.8 volts. So why are we only getting 20 amps? I'll let you know. Go into settings, then we do have the option to change to charging current settings, and we can see, now you can see, it's only at 60%. Let me zoom out, because you want to see that one. I hope it's hard to read right now. I'll increase this to 100%. Let me show you, it is 100%, right? So I'll hit enter. And now it's changing to 30.5, 30.6 amps right now. I'm in AC priority mode and it should charge, right? When it's in battery priority mode and there is no AC connected, it cannot charge the battery. So you need, as I mentioned, you need to have your solar coming in. Unattended might be something you want to use, so it switches back and forth, whatever you want to, but it's really up to your setting. When you live in a camper van, you want to have the battery priority. You need kind of a solar charger to charge the battery separately. When you are at home, you want to use it as a UPS for your computer, for your fridge. You want to have it in an AC priority, and the battery is connected and continuously charged, topped off ideally. Yeah, that's kind of also another use case. And here we can see now the battery is being charged. So the test we did previously, the wires got freakingly warm. Not freakingly, they were really hand warm, more than hand warm, sorry. The terminals were freakingly hot, so this battery really, we overdid it almost with the battery, but it didn't shut off, so that's what it is. I think, as I mentioned, battery was linked already. So we definitely did pull with 230 amps already, 2760 watts, and not continuously, but for a longer time of period. Just to give you an example, 2000 watt is equals 167 amps. 2000 watt is equals 167 amps, and we were continuously pulling that earlier already, pretty close. So let me do this with AC connected. So me turning on the heat gun. There's a little drop in the charger really quick, but then it's lowered up to 60, and it's purely pulling from the AC, from the grid, and charging the battery at the same time. When I overdo it, that's what I want to do really quick. Plugging in another source. You can see it's pulling 87%, 97. Now I'm pulling over 104, and the battery is still charging at the same time. I think we got close to 2000 watts, probably a little bit above, maybe a little bit below. Let me see how much I have to crank up. That is really nice and impressive. It's great to see. In this mode, when I want to turn off the inverter or the power, a long second should do the trick. It looks like, as I mentioned, it turns off the inverter. Nope. Oh, there we go. It does charge the battery again. The inverter, in quotes, the outlets are closed. The wire to the battery is cold. There was nothing pulled. It's just 30 amps coming in. Good to see. Alrighty. I actually do like, first of all, this remote panel is really nice to have. So when you want to route it somewhere else in your camper van or wherever it is at home, and you have the inverter somewhere stored behind, you can always turn it on and off with this one. And does it actually work? So on off, when I push it shortly, one slow second, turns on and off the inverter. Here it is back on. See the output. And I put it to low, turning off the heat gun really quick. It's still charging, and you can see the battery was actually depleted more than I thought because it was not charging when I did the testing earlier. That was the first time it happened. Before it was not happening, so I had to completely power the device off, and now it's not a problem. Maybe because I was switching all the different modes back and forth all the time. Well, it's something to keep in mind. That might be something you're not doing continuously anyways. Now I want to see when I push it a long time. There's nothing happening. There's nothing happening, so I cannot really turn it off another way. The only way I know to turn it completely off is to unplug everything, it looks like. Or you have it in a different mode, like the unattended mode or the eco mode. Since there's not a good manual about this part, I'm not able to really know how I test it. I have to figure it out myself, or maybe the manufacturer can give me some details on that and I can put in a different video. But I think that's all for this video. Let me know if you want to see something else for this unit. Oh, I didn't mention Bluetooth. This device does not have it. You have no chance of monitoring anything remotely besides with this little remote controller, which is wired. It does have the same functionality like the display back there. Would be great to have some kind of remote tools for this as well, because I think it's very capable. The manuals, it's lagging a little bit on that part. It would be great to see more. I hope this video helps you to determine a couple of things. The 5 different working modes, I think it's something which you have to know what you actually want and if this unit is something for you. Okay, so I'm now looking also here at the description on Amazon, just Amazon. So the battery priority mode and the unattended mode have low volt resource setting and low volt protect setting for the battery itself. Those are the only modes. And additionally, protections, it has a battery low voltage alarm, battery high voltage alarm, over temperature protection, I guess for the inverter itself, which I didn't trigger yet. Overload protection, we saw the fault coming on when it was more than 100% or close to 100%. And a short circuit protection, 110 to 120% of the output was maintained for 30 seconds. Yeah, that's for sure what we did already, and way more. Not 30 seconds, maybe less. Then output turned to bypass, more than 160% maintained to 303 milliseconds. Yeah, milliseconds, seconds. There are a couple of typos we have to talk about. I'm more than happy to help with that, to correct them. But what you can see, and that's interesting, battery type setting, choose SLA, HEM, gel, lithium-ion battery, and custom. Support, and that's what's interesting, lithium, iron, for PO7. So I would assume this means lithium iron phosphate. I'm not certain. Maybe that's something they can correct as well. I showed you can adjust it. It's just a question if it's good to have continuously charging a battery, or have you continuously for the lithium iron phosphate at 14.2 or 14.6 at the charging voltage, continuously having that topped off. Lithium iron phosphate doesn't need that. It's good for the car batteries, the AGMs, for example. That works pretty well there because they like it. That's the chemistry, but lithium iron phosphate, correct me if I'm wrong, doesn't need that. It can be emptied to 0, which is also not ideal, but it would be possible, right? And adjustable charging current, we saw that it's possible. 30 amps was the max I was getting, 30.5, 30.6, not a 35. Maybe there's a different setting which I have to use, maybe a different type of battery. I didn't test it with a different type of battery because lithium iron phosphate is the most interesting chemistry at the moment. I feel like, of course, when you have a lot of HAMs at home or one or whatever, you want to just use as a backup. That works perfectly fine. And I'm pretty sure you can just use the profile which is in there and that works out of the box. All right, regarding the entire device, my thoughts are definitely positive. For the price tag, in my case was this one. For the price tag, I felt like it's a good value. Compared to the blue one, the more expensive one, it has a lot of features which I enjoyed. It's definitely has a higher price tag in terms of when you just want to have an inverter, but it's a charger and inverter in one, plus UPS functionality. So it has a couple to offer, a couple modes as well to offer. And that's something which I think is amazing to see. And I think in a setup with a solar charger, maybe you have, like in a camper van, a trailer or whatever, and you have a plug outside, you can plug it in from time to time. You can then change the setting to AC priority or whatever. I think that's pretty interesting to use as well. It doesn't come with any Bluetooth remote features, whatnot. Can you parallel it up and stuff like that? Honestly, there was no information about that. I can only use this device with a 12-volt system, so 12-volt battery. It didn't say if there's a limitation in terms of 200 amp hours or whatever, so I figured my 200 amp hour is good. I'm pretty sure you can go higher because it measures it on the voltage, so that should be fine as well if you go higher, if you have more or less. And yeah, I think in general, when I look at the device, it looks solid. I didn't open it up yet. That's something for another video. But so far, it worked pretty good. The only thing one time was with the charging the battery. I had to reset it, disconnect everything, and restart it. And then it was starting charging again. That was the first time which I encountered it. And I used it a couple of days already. I'm going back and forth, letting it run just continuously during the day and stuff like that. So I can see a more longer term test. And if it actually works, so far it did work. And I do like the remote display, which is optional. So you have to pay for that on top. So let me know in the comments below what you think, what you want to see additionally. Is there anything you need me to test or want to see for this unit? And especially compared to the more pricier options out there, what are your thoughts about that? I'm really curious about it. All links are in the description below in case you want to do more research on that. And thanks for watching. Cheers!